Okay, so let us start today the next chapter, atoms. Right, so atoms chapter, although looks a small chapter, but there are many things in this chapter. We will try to cover as many of topics as possible. So let us start atoms. Atoms. So first thing is that what are we going to start first here? What atoms? So some important thing that we know is what is mass number, what is atomic number. That you already may be knowing about that, but let us know about mass number. Mass number. Mass number is represented as A. It is the sum of neutrons and protons. And atomic number is equal to Z, is the number of protons. Okay, right? Then in this chapter, first, there are various theories, various models of atom. People try to know what is atom, starting with the Thomson model and so many things, right? But you have studied those things right from the very beginning, from grade 8, 9th and all that. So here we will focus more on calculations. So that will start from Rutherford model. Rutherford model. Okay. Various model of atoms are there. So let us try to finish the things which are urgently needed for calculation. Okay. Otherwise, theory things you can definitely read from the NCERT. That will be helpful. Right. So Rutherford model of atom we will discuss. Rutherford model of atom. It is also known as planetary model of atom. Planetary model of atom. So, what is the other Rutherford model of atom is that he did alpha scattering experiment. You know that, right? Alpha. It is based on alpha scattering experiment. Based on alpha scattering experiment. Alpha scattering experiment. So in alpha scattering experiment, the alpha particles are projected to very high speed. What is alpha particle? Alpha particle is nothing but it is helium nucleus. Helium nucleus means helium plus 2. Okay. So this is what is alpha particle. Alpha particle. So what is the charge of alpha particle? Charge is plus 2 electronic charge. That's the charge. And what is the mass of alpha particle? Mass of alpha particle is 4 times mass of protons, almost 4 times mass of proton. And what is mass of proton? Mass of proton is nearly 1.67 into 10 to the power minus 27 kg. Okay, this is the mass of proton. Okay, so this alpha particle is projected with very high speed, and there is a gold foil, and gold foil means very thin film of gold. It is very thin sheet of gold. It is. So these alpha particles are going and striking, and he found out that most of the alpha particles are just passing through it. Most of the alpha particles are just passing through it, right? Then what else? Most of alpha particles just passing, but he observed that only a few alpha particles is showing little bit deviation, a very small deviations it is showing, not much but little bit deviation. But he found a very small number is showing a large deviation like this, very small number. So from this alpha scattering experiment, he made some conclusions. What are those conclusions? He concluded that alpha particle is bouncing back, means alpha particle is positive charge, right? So there must be some positive charge where it is trying to hit that, right? and that positive charge is the center of atom. So from this, he concluded many things, right? But most important idea what he concluded is that most of the atom is empty. Most of the atom is empty. Okay, and the almost all the mass, all the mass of atom is concentrated at its center, at its center, and the center, the center of atom, center of the center of atom is positively charged, positively, positively charged. Okay, so these were some of the ideas what he had got. Okay. And so he gave his model that this electrons, of course he gave the planetary models that electrons goes around the nucleus and so on. Later on that history of science we can see that. But from here he concluded about the nucleus, that nucleus is made up of positive charge, right? Protons. Other things were discovered later. Okay. So if you want exact theoretical points, let me just tell that. But that will be theory, right? So let me write the important thing first. Yeah. Okay. So those things are there. We will see that. So here, what is calculation he is going to do in this? So suppose, for example, this is the atom. Okay, atom, center of the atom is positive charge, and this is whole atom. Let us say as a sphere, and alpha particles are going. And I assume that this is directly going to in the same straight line it is going. So this alpha particle has kinetic energy. Some kinetic energy it has. So of course, it is found that if it is going like this way, somewhere it will retract its path, somewhere it will return. So this is point where it is going the nearest distance. This nearest distance is called distance of closest approach, d. So this is the distance of closest approach, distance of closest approach, and this closest approach distance d. So we want to calculate suppose this. Okay. So first of all, initial distance between them is infinity. You take that initial distance is infinity. Final, that is the distance, right? And initial kinetic energy is there in the alpha particle. Finally, when it stops here, it doesn't have any kinetic energy because instantaneously it stops here and then it retracts back, right? So we can apply energy conservation between this point and this point. Apply energy conservation. So what is the total energy initially? Total energy initially and total energy finally, let us apply. So initially there is kinetic energy, and initially there is no potential energy. Potential energy between this and that nucleus is zero. Finally there is kinetic energy zero. Finally only there is potential energy. Which potential energy? Electrostatic potential energy. So that means initial kinetic energy of alpha particle, which you can write half m v square. It is going with the speed v, mass is m. This is going to be potential energy. Potential energy, if you remember, 1 by 4 pi epsilon naught k q1 q2 by r, because they are charged particles, right? So between charged particle, potential energy is k q1 q2 by r. So k is 1 by 4 pi epsilon naught q1 q2. Charge of alpha particle is 2e, and charge of this atom. So remember, this mass atomic number is z. So there are z number of protons inside the nucleus. So this charge is plus Ze. Okay, charge of the nucleus is plus Ze because Z represents number of protons inside the nucleus. Right. So okay, Q1 Q2 by R means this closest distance D finally. Okay, so from here only we will be solving the closest distance. Okay, closest distance D can be calculated as, this is kinetic energy. If you want, you can keep this as kinetic energy. This will become 2 Z E square by 4 pi epsilon naught into kinetic energy of alpha particles. Okay. So like this we can solve the distance of closest approach. Sometimes they can give you the momentum. So kinetic energy can also be written in terms of momentum E square by 2m. Sometimes kinetic energy can be written as charge into accelerating voltage. So charge is plus 2e into accelerating voltage is delta v. So like that you can write kinetic energy in different ways according to question. Right? Okay. Then. So first topic here is to calculate this distance of closest approach. Now second point I will write some, this was the first formula, so let us write down some formulas. Second thing what you need to note is the number of alpha particles. Number of alpha particles scattered at an angle theta. That number of alpha particles is given as q n t z square e power 4 8 pi epsilon naught whole square r square e square. E means this kinetic energy alpha particle square sine power 4 theta by 2. Now you may say, what is this? Such a big formula. So do not worry here. The idea is that you are throwing these alpha particles, right? Alpha particles are projected with the kinetic energy of alpha particle. Now, as it is hitting this gold atoms, so these are scattering at some angle. That means this alpha particle, let us say it goes at some angle. So what is the scattering angle? This angle is the angle with this angle, what it is, that is what is theta. So the question is that how many alpha particles will be coming at this angle theta? There will be many alpha particles can come, right? So many alpha particles can have the same angle theta. So that is the number of alpha particle which are coming at that angle theta. So what is capital Q here? Let us write capital Q here is the total number of alpha particles striking the foil. Total number of alpha particles which are hitting that foil. Okay. Small n is what? Small n represent number of atoms per unit volume of foil. How many atoms are present per unit volume of the gold foil? What is small r? Distance of screen from the foil. Screen means you will be keeping here some screen, right? Some screen you will be keeping here. So these alpha particles which are coming here, it will be hitting to this screen. So distance from the foil and this is screen, this distance is what is r here. Okay. P is the thickness of foil, Z is atomic number of foil. Tell me, what is the atomic number of gold? You may be knowing about it. kinetic energy of alpha particles. Okay. That so that value we will use. If it is gold foil, then we'll use 79. If any other foil is there, metal, depending on the metal foil, we will change this Z. That's the formula for this. Not this. Um, Okay, so done. So here, what you need to remember is that n depends on what. So this n depends on thickness. This n depends on atomic number square. This n depends on 1 by sine power 4 theta by 2. This n depends on 1 by kinetic energy of alpha particle square. This n depends on 1 by alpha particle speed power 4. Okay, so I think here you need to just know, because in NEET questions they may ask this. They may give, suppose if angle change from this to this, if thickness of the foil change from this to this, atomic number means gold, instead of gold we use silver foil, instead of kinetic energy doubled, speed is doubled. How will the number of alpha particles coming at a particular angle, scattering at a particular angle will change, right? So they will ask shortcut questions on this. Then the next thing that we need to know is the impact factor. Impact factor. So impact factor means suppose this is the atom gold foil, and you are throwing the alpha particles not in a straight line, but there is a distance, there is a separation b. This separation b is called impact factor. Okay, so you're throwing it like this. So how is this scattering will depend on this impact factor. So it may scatter at some angle theta. So this angle theta and impact factor is related by this formula, z is square cot theta by 2 divided by 4 pi epsilon naught into kinetic energy of alpha particles. Okay. Suppose if you make this b as 0, suppose you make b 0. If you make b 0, then cot theta by 2 0. Cot theta by 2 0 means tan will become infinity. That means theta will be very large. Theta will be very large. So that is what happens. That means if you decrease b, theta will be large. If you increase b, theta will be small. Okay, that is what it is. If b decreases, B decreases means theta increases. And if B increases, then theta scattering angle decreases. Not a direct relationship is there, but from this we can say that. From this relationship. Right? Done. Okay. Then in the Rutherford tried to do some calculations. Okay. He gave planetary model of atom by Rutherford. So in the planetary model, what he says that the atom has a center plus and the electrons are going around it just like planets are going around sun. Okay, in a circular path, he's saying it's a circular path. Circular path. So in this circular path now, uh, there must be a centripetal force towards the center. Now this force is coming due to the attraction forces. Suppose this is the charge Ze plus Ze for this, and charge of electron is minus, right? So there is attraction between them. That force of attraction, which is electrostatic force, 1 by 4 pi epsilon naught, charge Z magnitude we are writing by r square, right? Electrostatic force. This distance is r. This electrostatic force is the uh, force of centripetal force, that is. Centripetal force is mass into centripetal acceleration, which is v square by radius. From here, radius term will get cancelled, and v square, if you want speed, so v square will come from here, z e square by 4 pi epsilon naught mr. So from here, speed can be calculated root under z e square by 4 pi epsilon naught mr. Right? We will be able to calculate the speed. We can calculate kinetic energy and potential energy also. So suppose I want to calculate kinetic energy. Kinetic energy is of course half mv square. So mv square already we got it. So half, this is mv square. So substitute here 1 by 4 pi epsilon naught z e square by r. So that kinetic energy become 1 by 8 pi epsilon naught r z e square. Okay, this is kinetic energy of electron. And what is potential energy? Potential energy is electrostatic potential energy, which is 1 by 4 pi epsilon naught q1 q2. Charge is, now here in potential energy we have to write the proper sign, you know that. K q1 q2 by r, we should write the proper sign. So k is 1 by 4 pi epsilon naught q1 q2. So plus Ze, which is charge of atom, and this is minus c, k q1 q2 by r. That becomes minus Ze square by 4 pi epsilon naught r. Now if I calculate total energy, we will add kinetic and potential. So total energy is equal to kinetic energy plus potential energy. So if you add them, 1 by 8 pi epsilon naught Z square by r minus Z square by r of 4 pi epsilon naught r. So that total energy will become negative 1 by 8 pi epsilon naught Z square by r. Right? Become minus because 1 by 8 minus 1 by 4 gives minus 1 by 8. So total energy of the electron in the atom is negative, means electron is bound system. Electron is not free to move, it is bound with the nucleus. because whenever energy is negative means there is attraction is happening, right? So that's what you can see. Then we can start the Bohr model. So almost all the calculations coming in Rutherford model will be limited up to this many formulas. Okay, so now let us start Bohr's model, and first we will note the important postulates in the Bohr. But Bohr model will also do calculation. But see here in Rutherford, he could not calculate the radius. He had that means you should know radius, then you can calculate everything. If you know radius, you can calculate speed because other things you know. Radius should be known, but he does not know radius, right? So because these equations are good equations, but he could not calculate anything from here. But Bohr was very successful model for which he got Nobel Prize. So Niels Bohr, he could do almost all the calculations, but he extended his model and he brought some important concept of quantum physics was developing since a long time. Okay, so that time quantum physics started very long time. So here his Rutherford model failed for several reasons. So Rutherford model had some drawback, and one of the major drawback of Rutherford model is uh, due to Maxwell's theory. So Maxwell theory of electromagnetic wave, Maxwell theory of electromagnetic wave poses a serious problem, serious problem to Rutherford model. And what is the serious problem? The serious problem is that a charged particle, a charged particle under under acceleration emits electromagnetic wave. So here the electron which is going in a circle around the nucleus must emit electromagnetic wave according to Maxwell's theory, right? It must start emitting electromagnetic wave. And if it starts emitting electromagnetic wave, then what happens? Gradually it will lose its energy and gradually it will fall inside the nucleus, right? That means this model of atom is not a stable model of atom. So it is an unstable model of atom. Because it is an unstable model of atom, it was not accepted by scientific community. And moreover, there were many things like, for example, Rutherford model could not, but this was the main problem. Rutherford model also could not explain the emission spectra, atomic spectra. So Rutherford model could not could not explain could not explain atomic spectra. So what is atomic spectra? At that time, people were discovering that atoms can emit some kind of radiations, right? Suppose you excite the atoms with some radiation, then atoms will absorb certain kind of radiations, and atoms can emit also certain kind of radiations, which have different kinds of wavelengths. So those wavelengths or those kind of radiations, they are called atomic spectra. One is called absorption spectra, another is called emission spectra. So these absorption spectra or emission spectra could not be explained by Rutherford model, right? So there are many other demerits also, but these are few important things which was not explained. Then Bohr has given his model. So let us discuss Bohr's model, Bohr's postulate. Bohr's postulate. So first postulate of Bohr addresses this issue because he brings the concept of quantum physics. He says that electrons are definitely going in a circle around the nucleus, but the orbit has energy. It is not that the electron has energy so it can go anywhere. No, electron is having energy because energy is present in the orbit. So he gave the concept of cells, energy cells, which he calls as discrete energy cells. Okay, so electrons revolve around nucleus in certain discrete energy cells or orbits. Electrons do not lose energy. Electrons do not lose energy when revolving in a particular orbit. So if electron is revolving in a particular orbit, right, it is going around some orbit, it is not losing energy. That means then the problem is Maxwell was posing this problem, but how to address them? So that's what he is using. That energy is fixed in this orbit. Okay, discrete energy cells. So this discrete energy cells brings the idea of quantum physics. So he says that electrons can revolve around this in certain discrete. Suppose this is this atom, center of the atom. So there are different orbits which are different energy levels starting from n equal to 1, n equal to 2, n equal to 3, n equal to 4. This is called principal quantum number. Principal quantum number. So electrons can only revolve only in these orbits. Electrons cannot be present anywhere else. So either electron can be present in first orbit or second orbit or third orbit or fourth orbit. These are certain fixed energy cells. Energy of the electrons in an atom is quantized. Quantized means energy will be present only in fixed manner. Suppose 10 joule. 10 joule, it will be present in terms of 10 joule, either 10 joule or 20 joule or 30 joule or 40 joule, like that. It cannot be 15 joule. It cannot be 25 joule. Are you understanding? Just like charge is quantized. Charge of a substance is n times electronic charge. It cannot be half of electronic charge. It cannot be 1.5 of electronic charge. That is the idea behind it, quantum. Okay. So this idea was a very good idea, and it's resolved the problems of that Rutherford models. Then second idea he gives that electrons are revolving in certain orbits where the angular momentum of that orbit is integral multiple of h upon 2 pi. Right? So he gives this idea that angular momentum must be integral multiple of h by 2 pi. That means nh by 2 pi. In the first orbit, it has a angular. L is the angular momentum of electrons in nth orbit. We can clearly see that angular momentum is also quantized. Why he does that? He he has not explained this, but he has just assumed it. But later it was explained. Later, due to the wave nature, it was explained. Okay. Then next third point is electronic transition, which explains the atomic spectra. Electronic transition. So electrons can jump from one level to a higher level. Suppose this is the atom. and these are energy levels. Suppose electrons are present here, the lower, this is called unequal to 1 is called ground state. Ground state. So if you give photons, photons means electromagnetic waves. If you supply photons, so electrons can absorb that photon. After absorbing, it can jump to higher level. Okay, so let us say electron initially is present at this level. This energy is the lower level, and this is the energy of the higher level. And if electrons is jumping from lower to higher level, okay, lower to higher level, then the energy of the photons which you are giving, the photon energy, so energy of the photon energy must be the difference of energy of higher minus energy of lower. This is what it is. Okay, that's what it is saying. Similarly, what happens when electrons comes from excited state to ground state? Suppose electron is present in this higher energy level, and electrons is going to jump now. Okay, so it is going to jump in lower. So when it will be jumping here, then it will release photons or electromagnetic waves. So again, the photon which is coming out, the photon energy is going to be the difference of higher minus lower. Okay, and photon energy, you know that formula is H into frequency. So photon energy is H into frequency, Planck's constant that we can. So this explains emission spectra. This explains emission spectra, and this explains absorption spectra. Absorption spectra. Okay, so both the spectra, Bohr is able to successfully explain that. Okay. So today we have covered up to this much. Of course, there are many things in Bohr's calculations of everything, radius, velocity, kinetic energy, potential energy, everything is there that we will be covering up in uh, the coming classes. Okay, right? So done. Gradually we'll do that. So solve out problems, work out more questions. Just now before this class, grade 11, I was doing. So people were asking doubts. I was just taking doubts. So if you have doubts, feel free to ask. I'm always available to take up your doubts first because that is the most important thing to clear doubts. Okay. So once doubt is clear, then you will feel easy to solve problems, any kind of problem. Okay? Right. So let us meet in the next class. Then. Yeah. Anything else you want? Okay. Bye bye. Good night.